So you know what, I've never actually tried to place a supernova next to the black hole in Universe Sandbox Square, and I really wonder what's gonna happen if you do that. Let's find out. Let's actually play around with Universe Sandbox and find out what happens if a supernova goes off right next to a black hole. Today you're going to learn something through video games, and my name is Anton. Welcome to What the Math. And so for this particular simulation, I wanted to actually create something completely from scratch, and we're going to put a black hole. Let's actually just place Sagittarius A star, which is the supermassive black hole in the center of our own universe, of our own galaxy, sorry. And we're going to play around with a few stars around this particular black hole. So, hypothetically speaking, if you have any kind of a star, let's just say, let's just play Arcturus, for example, any kind of a star that is approaching the black hole, and it's approaching it in such a way that basically it doesn't actually just fall into it, but it just scratches the surface of the event horizon, kind of like this. This would hypothetically form what's known as the accretion disk around the black hole, and this star, depending on the size of the black hole, would actually get shredded into little parts, and you'll see this happen in a few seconds, and then form an accretion disk orbiting around the black hole. Now, this by itself should not really cause a supernova in any black hole, and interestingly, it normally doesn't. So we've actually seen many stars that got shredded by different black holes, as you can see happening right now. And this normally kind of just creates, well, it creates a bunch of gas, maybe a little bit more extreme than what you see in a game. And then there we go. So there is the accretion disk. The star gets shredded and sort of falls apart into little pieces. And this disk might either come back, like you see right there, and start orbiting around the actual black hole and form the actual accretion disk that will then get released as two projectile jets from basically the top and the bottom. These are called relativistic jets, and I've talked about this in one of the previous videos. This essentially creates the accretion disk that is very, very highly energized and very bright as well. And this is all essentially what normally happens when a star passes by like this. Now, how would the supernova occur, though? Well, this is where it gets really interesting. We didn't actually think this could actually happen. We know this kind of a mechanism works for nova, not supernova, and I'll talk about more about this topic in one of the future videos. But supernova are basically, or at least normally, events that happen for two reasons. So I'm going to place Rigel, a very large star, right here, and I'm also going to place Sirius B, which is a much smaller star. It's a white dwarf right next to it, just to kind of show you how different they are. Now, both of these stars are going to, or may actually, go supernova. Actually, Rigel very likely will, Sirius B very likely not so much, but many white dwarfs can. In case of a white dwarf, if it reaches a certain mass, specifically a mass known as the Chandrasekhar mass of about 1.39 masses of Sun, you can also see it shrunk a little bit, boom, it goes supernova. This is called a type 1 supernova. And now Rigel is covered in it, but we can actually just go in here and delete it, because we don't want it right now. Rigel is a supermassive star, and one day when it gets really, really old, or somewhat more old than this, let's just say maybe 500 million years, it's also going to go supernova. But this is what's known as a type 2 supernova. It's a lot more energetic, it's a lot more massive, and it's also going to create a lot more new stuff. And also, very likely will leave something behind. So in this case, Rigel will either become a neutron star or possibly a black hole. But we're not going to be talking about this just yet. We're actually going to be talking about the idea of this happening next to a black hole. And it's actually very, very unlikely to happen next to Sagittarius A star, because it's massive enough and it's big enough not to have a lot of tidal effects when you're close to it. But a much smaller black hole, like for example this one right here, that's only about 10,000 masses of Sun, is going to have a much higher tidal effects close to it. And because of this, it's a lot more likely to shred the star in such a way that it may actually go supernova. Now I'm going to place Rigel here again. Let's find it first. And let's place it in orbit around this black hole and make it go in circles around it. Although I think I should have actually used a much bigger black hole because this one is kind of hard to see. It's barely visible even. That's how small it is compared to this massive star. But you can see it's right away starts falling apart. It basically starts falling apart, starts getting shredded by this black hole and its tidal effects. And the black hole starts acquiring this beautiful accretion disk. And here's what's going to happen with time. This accretion disk is going to start spinning so fast and start to accumulate so much matter around this black hole that at some point it will become so dense and so hot that it may actually initiate a supernova. And this is something that we've officially observed back in 2015 in a system known as ASASSN15LH, also known as Assassin 15. We at first thought it was a regular supernova, and it was actually labeled as the brightest supernova ever discovered. But turns out that we may have been wrong. Turns out that it may have been not just a supernova, but it was so bright and so energetic because it was supernova around a supermassive black hole that caused the star to shred, to basically be ripped apart into pieces. Okay, this is not as fun as I thought it would be. Let's try it with the larger black hole. There we go, that looks a lot better. So as it basically gets shredded apart and gets sort of destroyed by the black hole, its matter gets so dense and so energetic that it just kind of goes boom. And you might actually see this anytime soon now, because in this game, there's currently a bug where the actual star doesn't really get, it doesn't lose mass when it gets shredded. And so if I were to increase the mass, or sorry, if I were to reset the radius of the star right now, you would see a very big boom. And there's our supernova. And let's actually just remove the star just for now. So this is basically the shredded star and the supernova that was created by Sagittarius A. And this is what it will all look like if, hypothetically, a very massive star approaches a black hole, gets shredded by it, and then sort of creates a supernova. Now, it doesn't look as impressive as you may have thought, and the supernova is actually kind of flying away from the black hole for some reason. But let's actually just place maybe another star here and do this again. We're going to create a much more beautiful, visually impressive thing here by essentially doing this several times. Look at that. You can actually continuously do this over and over and create these massive supernova around this black hole. And it will create this absolutely gorgeous and beautiful firework, essentially, in different colors. And that's why I love this game so much, just because it allows you to create these absolutely gorgeous effects. Now let's try this a little bit different. So this was an orbiting star. Let's actually just place it just right next to the black hole and see if we can maybe, just maybe, do something a little bit different. So this particular star is going to be approaching the black hole, and we're going to activate it right here. And there is actually a more realistic version of what may have been happening in that particular system that's about 3.8 billion light years from us. It may have been actually a star that sort of went supernova right next to the black hole. But unfortunately, the supernova is still flying away. But I think I can cheat the system if I do the following. I'm going to erase the star once again and place a star literally right next to the black hole. So there we go. Now we're going to just go in here and go boom. And there's the supernova right next to the black hole. That's how it's done. And so this will actually, or this has actually probably covered the black hole, but a lot of this material around the black hole would obviously right away get absorbed by the super strong gravitational effect. So there will be actually a black hole within the supernova, which I'm not sure if I can recreate. I don't think I can. But around it though, everything around it would still be very, very ultra highly energetic, very, very bright. And it created the largest or the most luminous, the most bright supernova we've observed to date. It was basically the brightest event that we've discovered in the night sky until today. And the only reason people thought it was not a typical supernova was because of the way that it actually started dimming or started to decrease in the light with time. So like a lot of this started to kind of disappear and became darker and darker a lot sooner than other supernovae usually do. And people started to realize, or the scientists started to realize that maybe, just maybe, it's because something is absorbing the material and sucking it back in. So it's very likely that it's actually the supermassive black hole that started to absorb a lot of this stuff and made the supernova lose luminosity a lot sooner than these other ones that you see next to it. And so essentially, that's kind of all I wanted to show you in this video, and that's all I wanted to talk about, and kind of wanted to explain to you how this one day may actually happen. We might one day see a very luminous supernova in the sky, and it's probably because it happened because of a black hole. It basically happened because a star, or in this particular case, maybe several stars, approached the black hole relatively close and got shredded by it, and the material released from the black hole created this amazing accretion disk that then accumulated to the point where it initiated the supernova. So this is something that we think does happen, and we think we observed it back in 2015. And there we go, we're going to try to initiate another supernova, maybe this time a little bit more manual, by essentially causing a lot of these stars to go supernova right now. And there we go. Boom. Look at how gorgeous and beautiful this is. So there are our 3 supernova of 3 different colors around this beautiful black hole from those 3 beautiful stars.
Anyway, thank you so much, wonderful person. I'll see you in the next video. Please subscribe if you still haven't. Possibly share this video with someone who enjoys watching these types of videos and wants to learn something through video games. And maybe even consider supporting us on Patreon, because it does help me purchase better equipment for future videos. Thank you, game you later, and as always, bye-bye.